In lesson 3.3, we will look at logarithmic functions. I have about 5 learning objectives that I want to go over in this lesson. I'm going to probably divide up the lesson video in 2 pieces instead of recording a single long video. So let's try to go over learning objective 1, converting, evaluating, graphing in this video. And I'll come back and go over how to find a domain and maybe just a single application problem, okay? So last lesson, you learned about exponential functions. The inverse of an exponential function is called logarithmic function. Just like how you know, let's say, if you have f of x, whoopsies. If you have f of x, I'm going to just write a function that you know about. Say that the function is, say, x to the third power. The inverse of this, I mean, we can write it real quick. We can say switch to x and y. And then to solve for y, you take cube root of both sides. So y is cube root of x. So the inverse function for x to the third power, cubic function, will be a cube root function, right? And if I use the inverse notation, I can say f inverse of x is cube root of x. So just like how cube root function and cubing function, those are inverse of each other, log function and exponential functions are inverse functions. So eventually, probably in the next lesson, because today I just want to go over the basic log. I want to practice what we learned in unit, the first section, 3.1. We learn how to write inverse function by switching x and y. I want to do the same thing for these logarithmic functions or exponential functions. We want to go from one function to the other, just writing the inverse function. But we'll get to that. But first, let's talk about what logarithmic functions are, okay? All right, every exponential function is one-to-one function and therefore has an inverse function. The logarithmic function, so we have it right here, f of x equals log base a of x. Oopsie. Log base a of x. Now, that little a you see is a subscript. That's a base. That's going to be the log base. Let me write it. Log base. So log base a of x. But remember, 2 things. This base has to be greater than 0. And it cannot be equal to 1. Now, it sounds a lot like what we talked about in 3.2 lesson, right? Remember, in a exponential function, let's say g of x, we can have, let me see, a to the x power. Remember, this base had to be greater than 0. And that this base cannot be equal to 1, right? So that log base, if we rewrite this in exponential form, it will be the base of the exponential form. So we'll get there. We'll go from going from log to the exponential function. But just want you to know this tiny little number a is going to be replaced by a number, but it has to be positive and it cannot be 1, okay? Look at the domain and range. Remember, exponential functions' domain was always all real. Now, these are inverse functions. So the range for the logarithmic function is actually going to be all real, okay? But the domain is going to be from 0 to positive infinity. Now, this is really just the domain and range switched, right, from the exponential function. So you've seen this in 3.2. We're just switching the x and y. Remember, the exponential function had a horizontal asymptote at y equals 0. This guy, the log function, has a vertical asymptote at x equals 0. Okay, so they're gonna connect. We're gonna graph both of them in a single graph, and we'll see that they are inverse of each other. Okay, let's define what it is, and let's do some rewriting. I got some properties to go over. Right, the definition of a logarithmic function: the logarithmic function with base a, where a is greater than 0 and a cannot be equal to 1, denoted by log base a of x, is defined by this. Now we're gonna practice this, so don't worry. We're going to go from this orange form on the left, the log form. So that's the log form, okay? And we're going to go to this green form. And this green one is going to be the exponential form. let me give you a couple examples, okay? Let me make a very obvious statement. You know that 3 squared is 9, right? This is an exponential form. What we're trying to do is we're going to rewrite this as a logarithmic form, okay? So this is how it's going to go. You write the log, and the questions that I will be asking is, what is the base? The base is 3, right? Base is 3, so you write the 3 tiny, and then you write the 9 right next to it, and then you set that equal to the exponent, the power of 2. So we're going to go from exponential form to logarithmic form, and then logarithmic form to exponential form. That's one of the first thing that I want you to practice in the, lesson 3.3. And I made up a little quizzes where you will, try a couple of these. So maybe just one more. But that's what they are saying. This orange and the green, that's what they are saying. One more. How about if you have 5 to the third power? 5 to the third power is 125, right? So we know the exponential form. We know how to read it. We know what it means. 5 to the third power is 125. Now, if you write this in logarithmic form, you first need to write log, right? What's the log base? What's the log base? Base is going to be 5. And then you write 125 right next to it, okay? And that equals to the power or the exponent of 3. Okay, hopefully you're okay going from exponential form to the log form. Try this. How about you try this? I'm going to make up another one. Try 4 to the negative second power. And what's that going to be? If you raise 4 to the negative second power, well, that will turn into 1 over 16, right? Try to write this in logarithmic form for me. Stop the video and try to write this in exponential form. I'm sorry, logarithmic form, okay? All right, did you write it? It should be log base 4 of 1 over 16th equals negative 2. So we just looked at maybe 3 examples of going from exponential form to logarithmic form. You see where things are moving. The base stays as the base. But, now let me see. Because I'll be calling this is the log base. This is the log base, which is just the base of the exponential form. And we call this part, it's the log, or the argument, log argument. And that argument is going to be the answer in the exponential form. But, you just got to kind of practice going from one form to the other. And we'll do a lot. You know what? Let's actually do that first. Let's do page 2, where we're just going from log form or exponential form to the other. Let's do page 2, what we just kind of saw. And then we'll come back and talk about these properties and the other ones, common log and natural log. All right. Learning objective 1, convert between logarithmic and exponential form. Example 1, we want to write each equation as requested, rewrite as logarithmic equation. First, we have 25 raised to the negative 1/2 equals 0.2. Let's write the log form. I mean, if you want to write the log form, you need to write log, right? And then what is the log base? The base is 25, right? So you write the 25 tiny as a subscript, and then you write the answer on the other side, 0.2. Log base 25 of 0.2 equals negative 1 over 2. So that's going to be the answer. Now, some of your calculators have log base. I know your TI-84, if you click on math, you can scroll all the way down and find a button called log base. I don't know if I have that on my free app that I downloaded. Let me see. If I go to math, I think they have it. Yes, you see how down here I have the log base, and I forgot the number. What was the number? Let me go back. Log base 25.2. So I'm going to type that in, log base 25 of 0.2. What do we want to see? We want to see negative 1/2. Negative 0.5 is negative 1/2, right? So some of you have your scientific, or I'm sorry, graphing calculator that does have a log base button. So, and you can find that if you click on math, and then if you're gonna have to scroll down a little bit. This looks a lot like TI-84 calculator, but log base is what you want to open if you want to evaluate these, okay? All right, so that's how we do it. Now let's try the other way around. Rewrite as an exponential equation. So this time we got a log expression. Log base 2 of 8 equals 3. Let's write that in what form? Exponential form. So what is the base? What is the base? Base is 2, right? So write the 2 as the base of this exponential form. And what's the exponent? Exponent will be 3, right? And that equals what number? What's the only number left? 8. Now, see, that's true. Is 2 cubed really equal to 8? 2 times 2 times 2 is 8. So, you know, we're just like translating, like learning, I don't know, different language, different just way of writing things. But if you type in log base to 8 in your calculator, let me do that with you right here. Go to math, log base of 2 and 8 in there. Guess what we're going to have to get? We must get 3. So they're equivalent expressions. They're saying the same thing, equations, but they're just written in different form. So let's try a couple more. Well, that was actually it for converting. I know I'm going to ask you to do a lot of this practice when you're doing the quizzes, but let's evaluate some, okay? Learning objective 2 is to evaluate logarithmic expression. What they got is this. You know, the thing is, guys, if you have that TI-84 calculator with the log base function, I mean, you can check it. You should check it. Put on your TI-84, click on the button math, okay? And then if you go down, you'll see, I think it's option A. A says log base. If you have that function, you know, you can evaluate the log base in your graphing calculator. But if you don't, it's okay. I can teach you something called a change a base formula. Where is that? Oh my, it's not here. It must be in the other section. But you know, we don't even need this function. What we can do is we can try to rewrite this in exponential form. So let me do that, in fact. Say that we want to evaluate this. So I'm just going to call this x for right now, because I don't know what that is. But if I rewrite this in exponential form, that will be 3 raised to the x power equals 27. Now for this one, we can think about this. How many times do you have to multiply 3 by itself to get 27? Isn't 3 times 3 times 3 27, right? So what you know is 3 cubed is equal to 27. So what must be the x value? X must be 3. X must be 3. So if you can figure out what the power or the exponent has to be to make 27, we can do this without a calculator. But I can also type it. Take a look. I go to my calculator. I'll go to math, go to log base, and type in 3 in the base. And what number in the argument? 27. And if I hit enter, I will get 3. So if you have a calculator, I don't mind, use it. You can use it. All right, so let's look at another one. I'm going to have to... Now, you see, this one's a little different. Now, take a look real quick. I'll just ask you to look at B, D, and F real quick. D base is 4, right? F base is 5. Look at this one. There is no base written. What that means is this is called a common log, guys, okay? When the base is not written, that means the hidden base is 10. So this is called common log. Common log. And when the base is hidden, it's not written, the base is going to be 10. So what we want to find is log base 10 of 1,000. In exponential form, what that means is, I'll call it x again, 10 raised to the what power will give you 1,000, right? X has to be 3. right? X has to be 3 because 10 times 10 times 10 or 10 cubed is going to be 1,000. So we already know that X has to be 3. Now, I know that the special function log base is not available on everybody's calculator. But guess what? Good news. Common log is available on any calculator. And I think even on my iPhone, they have a common log button. So let me show you. Go to your calculator and find the log button. You see next to my 7 button right here, there is log. You click on log. And then I type in 1,000. And this is log 1,000 and it will give you just 3. Now, what about log million? 1 million. Log 1 million. What do you think the answer is? 1, 2, 3, 4, 5, 6. For million, we have 6 zeros. So the answer should be 6. Right. So what about log 10? Log 10. What's that going to be? It's going to be 1. So even if you don't have the log base button, you all have the common log button on your calculator. So we can evaluate these common logs. Okay. That's what I kind of typed up on the first page, the common logarithm. This is what we just kind of saw. The logarithm with base, it should say base, not base. Can you change that to base for me? The logarithm with base 10 is called common logarithm and is denoted by omitting the base. So if they just simply say log x, you know that's the same thing as log base 10 of x, okay? So we just talked about common log. There is another guy called natural log. And we're going to write ln, but we'll get there in just a second. Let's look at the other ones right here. Now let's try C. Now I'm going to try to do this by hand first. I don't know if it's going to work, but let's see. If I rewrite this in exponential form, I can write this as 2 to the x power equals 62, right? Now, is this doable by hand? Let's try that. Well, you know, not 2 to the 6 power. Why am I keep writing 6? 2 squared is 4. Let's keep going. 2 cubed is 8. What about 2 to the 4? 2 to the 4th is 16. 2 to the 5th is 32. And 2 to the 6th is what? 64. Now we got a problem. X must be a value in between what and what? It must be a value in between 5 and 6 because 62 is smaller than 64 but greater than 32. So we're expecting x to be a decimal, and this one we're gonna have to use the calculator. So this is what I'm gonna do. I'm gonna go back to calculator, go to math, click on log base, put the 2 in the base and put 62 in the argument. Now if I hit enter, I better see a number that's smaller than 6. And the answer comes out to be 5.954. So we're just going to round it, 5.954. The answer is, I'll say x equals 5.954. What they are saying is you're going to have to raise 2 to the 5.954-ish power to get 62. And this one I had to use my calculator because we don't really go around memorizing what the power should be to make 2 62. But, that worked. Next one, this one. Now, let's rewrite this one in exponential form. Write 4 as the base. But hold on, let me go ahead and call this x. 4 raised to the x power equals 1/2. And this is actually doable. This one is actually doable, but it's not too obvious though. Because if you think about this, you're going to maybe start at 4 to the 0 power is simply 1. 4 to the first power is 4. 4 squared is 16 and so on, right? It's not going to turn into a fraction. So what should it be? It's got to be a negative number. We're going to go down to a negative number and try 4 to the negative first power. That's going to be 1/4, right? That's not it. What about 4 to the negative second power? Oh, you know what? It wasn't even going to be negative. I'm sorry, I was wrong. Because if I keep on going, the fraction is just taking half and half and half. Not exactly half, quarter, and a quarter. So it's not a positive number. It's not a negative number. So what should it be really? Then now I'm thinking, let's think about this. I mean, I know I can do this on my calculator, but I just I wanna try this without it. Now, what do you have to raise 4 to? 4 to the what power is going to give us 2 or 1/2. Try this one for me. What about you take square root of 4? Wouldn't that give you 2, right? And square root is the same thing as raising something to 1/2 power, right? But if you want to make this a 1/2, it's not just going to be regular 1/2. It has to be negative half. So, I don't know if you're going to do this process by hand, if you have a technology that will help you on this. And, because I think that will be more efficient if you use your calculator, right? So, you saw me try to do this by hand, but I know the answer has to be negative 1/2. But let's try to type this in our calculator to figure out what x is. So on my calculator, I'll do, where am I? What's all this? Okay, log base 4, and the argument was 1/2, right? And if I hit enter, I will get negative 0.5. That's negative half. So the answer is x equals negative 1/2. Since now we are going online, remotely, and you have all these tools that you can use, it's my job to create something creative so that online calculators cannot solve all the problems for you. So if you want to use a technology to evaluate these logs, that's okay with me, okay? I'll just be very good at making up good problems that you cannot type up everything in your calculator. Now this one, natural log of 1. Now this one is a special log. Whenever you see this ln, this is called natural logarithm, okay? The base is, natural log of x is the same thing as log base e of x, okay? E is a number, okay? Just like, pi is 3.14, blah, blah, blah. E is going to be another very special number that we're going to talk about in this lesson, in this unit. You can ask calculator what E is approximately. We all have an E button, right here. I see mine right here. Second dividing, it got me E. If I hit enter, E is approximately 2.718. 2.718. 2.718. This is going to be a special number that we will be using. But this is a special base. So if we have log base E, we just call it natural log. Okay? So what they want is, they want you to find log base E of 1. That's what they're asking you to find. But here's the good news. We all have a natural log button on our calculator. Natural log of 1. Let's type that in. Okay? But, now here's the thing though. Before we just get so dependent on these technology, I want you to think about what this is. You're raising e to the x power, and then you're getting 1. There's gotta be one answer. There is that one answer that will make this equation true. X gotta be equal to 0. Why? Because if you raise anything to the 0 power, you will get 1. So we do know without typing this in our calculator that the answer must be 0. But let's see, ln. I want to show you that natural log button is on everybody's calculator. You see next to 4 or under log button, there's ln. Press that and do natural log of 1. It tells you 0. What about natural log of e? What do you think they will give you if you type in natural log of e? E to the what power gives you e? Well, that answer is going to be 1. Well, we'll say natural log of 1 is 0. So, wow, it's a very busy lesson. So many new ideas so far, right? But hopefully you are with me. I'm going to go ahead and do just this page, and I'll stop and come back and record the rest, okay? Because I think this is one of the big ideas that I wanted you to master. Log base 5 of 125. Let's rewrite this. 5 to the I'll call the other side x equals 125. Now, you can skip all this part if you just want to go straight to your calculator, right? You can type in log base 5 of 125, and they're going to tell you that x equals 3. Because 5 to the third power is 125. Let's check it. Log base 5 of 125 equals 3. So, and you can also check 5 to the third power equals 125. So they're saying they're the equivalent expressions. Go back over here. So the answer is simply 3. Now, you just looked at how to rewrite logarithmic form to exponential form, and from exponential form to logarithmic form. And also, we looked at two of the special log. The first one was common log when the base was 10. The second one was called natural log. And in natural log, the base was what? E. So those are the two special logs that I'm going to need you to know. In addition to that, we also use the calculator or the definition of log to evaluate some of these logarithmic expressions. I'm going to just go ahead and do example 3 too, because we're on that page. We'll do example 3, and I'll stop the video and come back and talk about graphing the log function and finding the domain of a log function. And just the other ideas. I think this lesson is a little busy, but it's all right. It's not like challenging, right? It's just we just have to cover a lot of different things. All right, example 3. Use the definition of the logarithmic function to find x. All right, so let's do that. Rewrite this as an exponential form. 3 to the what power? 3 to the third power equals x. Okay, so you're going to have to rewrite it in exponential form to figure out what x is. Well, we know what x is then now, right? What is 3 cubed? 3 cubed is 27. We found the answer. Okay, let's look at the next one. Log base 2 of x equals 5. What are they asking? What is 2 to the 5th power? That's what they're asking. So 2 to the 5th power is, was it 64? I forgot. Let me do. 2 to the 5th power is 32. 2 to the 5th power is 32. So we got it. And if you want to double check your answer, type this. What is log base 2 of 32? If you type that, we better get 5, right? Just out of curiosity, let's check it. What is log base 2 and 32? We better get 5, and we did. They all, I hope this is making sense. They look so different with this log expression, but they're not too hard, right? We're just going from one form to the other. All right, what about this? What's the base? Base is 3. The exponent is x, and that equals 243. And in this case, they want you to find what x is. 3 to the what power gives you 243? Well, we'll see. Let me just type in a couple numbers. What about 3 to the 5th power? Oh my goodness, that was it. 3 to the 5th power is 243. But you know what? Say that, we could have typed in the log base 3 and 243, and they would have said 5 right there. But you can check it either way. If you're more comfortable still working with the exponential form, and you got the calculator to test a couple of these exponents, then that's also okay. So x equals 5. All right, what about this one? Let's rewrite this in exponential form. X to the what power equals 1,000. What do you have to multiply 3 times by itself to get 1,000? Well, x gotta be 10, right? Because 10 times 10 times 10 is 1,000. All right, next one. Oh, maybe a little challenging. X to the 1/3 power equals what number? 3. X to the 1/3 power equals 3. Now this one's a little bit challenging. I like this. All right, so let me rewrite this, guys, okay? Because I want to solve for x, but what does it mean raising something to the 1/3 power? That's the same thing as taking a cube root, right? So if I'm trying to solve for x, what should I do to both sides? I should cube both sides to get rid of this cube root. If you do that, guess what? X equals 3 times 3 times 3. 3 cubed is 27. I got the answer to be 27. I want to check it. I want to check it by plugging in log base 27 of 3. If I type this, I know calculator usually gives me a decimal answer, but I want to see if that decimal is equivalent to 1/3. So if I type this in, I better see 0.3 repeating. Okay, so let's see. Go to log base 3 and then type in, what was it? Oh gosh, guys, I forgot my memory. Oh, it was 27 as the base. It was 27 as the base. How do I delete this? Oh, I cleared everything. 27 as the base, and then 3 as the argument. If I hit enter, I see 0.3 repeating. And that is, I think I can convert this into a fraction. Guys, I'm home now, so I'm testing all these different apps. If you like certain calculator app, let me know, because this is the one that I downloaded. I'm having fun with it, but if there's a better one, I want to know about it. All right, but anyways, this is gonna be 1/3, so we got the answer. We just kind of checked it. All right, next one, the very last one. And you're thinking, oh no, they didn't write the base here. Well, what must be the base for a common log? This is the same thing as log base 10 of 10 equals x. Okay, if I write this in exponential form, that will be 10 to the x power equals what? 10. What must be the x value? 10 to the what power is 10? X gotta be 1. 10 to the first power is 10. All right, or, you do have a button on your scientific or graphing calculator, the log button. Type in log 10. What will they tell you? It's exactly 1. So be smart about using your technologies because you have them available. But I also want you to know how to go from the exponential form to log or the other way around without the help of your calculator. So I picked a couple problems on this quizzes that just uses variables like random letters instead of numbers so that you can't really type those in your calculators. Now what I kind of did with you is just the basics of logarithmic and then just the definition. On the second video, I will come back and talk about graphing them, talk about domain and range, and how it is really the inverse of the exponential form. And then we'll talk about writing or finding the domain algebraically, okay? I'll see you